Question 4. So the question 4 of the junior O level 2019-4. Okay, what is it? You have 1,000 integers. Whew.
Whoa.
One. They didn't even write the second one. Okay, that's how
many
out of touch that number is. Okay, their squares are written in a circle. Okay. Okay, the squares are written in a circle. It so happened that the sum of any 41 consecutive numbers on this circle is a multiple of 41 squared. I feel like I remember this something for like a A level. Sum of 41 consecutive is 41 squared. Is that right? Mm-hmm. It's a multiple of 41 squared. Multiple of. Is it necessarily true that every integer is a multiple of 41? Okay. Okay. So let's go through hb's solution. It's out of 5 this time, okay? This is 5 out of 5, yeah. Oh, this one was marked by Dimitri.
Oh, great.
Dimitri
Badziarden.
Ah, isn't it? Dimitri Badziarden. Yeah. So the organizer, yeah? Okay, so let's look at hb's solution. Okay, for all ak squared, ak plus 41 squared equals a k squared. Oh, this is the most confusing first sentence ever. Mod 41 is kind of written up there like this. It's written like this, okay? As 41 consecutive numbers. So I'm starting a new line because I ran out of space. He continues. Numbers sum to, oh, and then 41 squared got over here.
What? What? Yeah. How lost is the solution?
So that's pretty funny. Okay, so I guess, so you must have inserted these things like afterwards. You also did this arrow thing like this, okay? Mod 1000. Okay. Okay, so the first comment I have, so this enlisted the marker to write Y in red pen, okay?
Why?
I think the question should have been what, yeah?
What?
Okay, so when you say for all ak squared, I think this habit you should probably get out of in senior is like make it clear it's for all the k's, yeah?
Oh.
For all k, yeah?
Not for all ak squared.
Because it's not clear what all the ak squareds are, you know what I mean? Okay. So, and if you want to be really precise, I mean, they could all have the same value, say, right? So then there's only like, you're talking, how many numbers are you talking about even, right? Okay, so for all this is for all the k. Okay. And so this is what you're saying. It's equal to this mod 41.
Yeah. Well, that's true.
And the k, what's this mod 1000 down there?
Oh, yeah. Because, like, he's saying k can be any integer, so, like, he's gonna do it mod 1000 to make them less than 1000. Yeah.
Oh, okay.
Yeah, because that accounts for the case where it's like 999 goes to like 40, you know.
Uh-huh.
Because normally that wouldn't be k and k plus 41, but mod 1000, that's true.
Oh, okay.
So it's like wonky notation.
Oh, because they're in a circle, right?
Yeah.
Okay, because they're in a circle, you can take the indices mod 1000, yeah?
Yeah.
And the thing will be next to them. So these will be next to each other, yeah? Yeah, so the market doesn't like to go through this process of figuring that out, okay? So, and then, and believe me, like, so stuff that you think is obvious, okay? Like, the markets may not think is obvious, okay?
Yeah.
Okay, so a squared, what's the mod 41 mean? Is that what this equals is? Congruent mod 41?
Congruent mod. Shouldn't it be 41 squared?
But obviously it's better to be right, because when they do figure it out, then they're happy they actually figured it out, and then they realize you're right, and they'll give you the mark.
Yeah.
If you make them figure it out and you're wrong, that's like you're losing the next mark for the next thing as well, you know? Okay, so mod 41, what's mod 41? The equation, right?
Yeah.
Okay, so why is that true? Why is it true mod 41? If you're adding 41 to the k.
You just do, it's because like you have the
Oh, because the
sequence.
sum of the consecutive, yeah?
Yeah, you have the sequence k to 40 and to k plus 1 to k plus 41.
Oh,
Right,
okay,
and
yeah.
they're equal, so you cancel out the middle terms, so then k
Yeah.
is.
Yeah, so you add,
Yeah, it's the same logic I use.
so is this exactly the, so how many terms are in between here? Is it 41?
Yeah, no, it's meant to be 40, yeah.
40.
40 between. So that means if you added 1 to each side of the 40,
Yeah.
that'll give you a new sequence of 41.
So the way I'm seeing it is you kind of just have the sum from here to there somehow, and then can mod 41 and those all the terms die,
Yeah,
and then they're equal, right?
Yeah.
But they're not. But are these? So these are both in a consecutive. I'm confused now.
So k to k plus 40 is one set of 41. Then k plus 1 to k plus 41 is another set of 41.
Oh, you're doing it that way.
Yeah.
Oh, so this actually is more complicated then, isn't it?
Yeah, you probably have to explain it. I explained it in my solution.
Or maybe it is being explained. It's just it didn't get. It didn't. Maybe that's why I got the y early, because you didn't say proof underneath or something. Maybe it is being explained now. So here it says, note that a1000 squared equals a2000 squared. What? What does that mean?
I think it's talking about the mod 1000 stuff for no reason.
Considering multiple cycles. What's equals a squared 41,000. Considering multiple cycles of a squared k plus 41 n. Okay. And there's an arrow pointed to this saying, let this denote the 41st time we have gone around the circle.
row.
Oh, okay. I see. And is the equality mod 41? Well, I guess it's the same. I guess this equals noting is the same as this arrow then. Okay, so note that, yep, since A1000 squared equals A16 squared. And A2000 squared equals A32 squared. A16 squared equals A32 squared mod 41. Huh. This is hard to follow, huh? What's going on?
He's just adding 41 a lot.
I'm taking the ball.
Oh, so this mod 41 is that? Yeah?
And probably.
It's 820.
Yeah.
Yeah?
Uh-huh.
180.
Yeah, 16.
Yeah?
Yeah, I calculated it.
Oh, so it's not explaining that, it's using that, isn't it?
Yeah, it's
Okay. Note that A1000 equals that. Why is that? I guess we're just labeling it like that way, right? Keep going around the circle. Okay. Oh, but if you apply that thing to this, you get a different answer, right? They're not off by 41, are they? Okay. By inspection. By inspection, 1000, 2000, all the way up to 41,000 have different remainders mod 41. Have different remainders. Now, why is that?
Kyle said because they co-prime, I listed them all out.
Oh.
2 ways to go.
Oh, so I guess you did list them out. So 16, 32, 7, 23. But you don't know what that means, and maybe he did see it by inspection and listed it out for the benefit of the marker. So maybe that's what moved Dimitri. Dimitri's, oh, I'm so moved by this gesture of kindness. It's no longer why, it's why not. Okay, so this was listed out. So 16, 32, 7, 23, 39, 40, 35, 20. Is there some kind of pattern here? We're just kind of adding 16, are we? Adding 16 mod 41, right?
Yeah.
So how else can we do that? So 16 multiples of 16 mod 41 are all different. Yeah?
Yeah.
Yeah, just because of co-prime.
Is that because of co-prime?
Well, I think that's some theorem.
Yeah, so it's the order thing, right? But it's for addition, yeah?
Yeah.
So if 16k equals 16j, right? Yeah?
Yeah.
Mod
Something.
p, yeah?
Mm-hmm.
Then k minus j equals 0, right?
Yeah.
Yeah? They're all different. Okay. Yeah, it's almost like you even felt bad about writing by inspection, so you wrote it out after.
Yes.
Okay, this means that a squared 1000 Actually, it's possible that it's in the rough working y, yeah? That's also possible.
Yeah.
Okay, the rough working is kind of funny too. You see the rough working. And that's it, that's just one rough working page. A big long list of numbers. Okay. So what does this mean? This means that a1 squared equals a2 squared equals a3 squared equals, you wrote a4 as well. A41 squared mod, well I didn't write mod 41, but maybe that's assumed now. As all ak squared is congruent to one of mod 41, it follows that all ak squared are congruent mod 41. What does that mean? What does that mean? This means that a to 1,000 what's a1? So this means that a 1,000 squared equals, so this came up here, and there was all this stuff was crossed out, and then this line followed, yeah?
Mm-hmm.
Mm-hmm. No, it's fine. I mean, everyone really did that, so that's it's a sure way. I guess it's hard for the marketer to really check it, because they either have a list of it or they have to calculate.
Yeah.
Yeah, but it's the same principle as the order thing, but for addition, right? That's some new technology. Okay, so as all ak squared is congruent to one of, as all ak squared is congruent to one of a1 to a41 mod 41, it follows all ak squared are congruent mod 41. Mod 41. Okay, what does that mean? Oh, okay. So it's saying that all the thousands, right? I'm starting to understand this. So these are all equal, yeah?
Yeah.
But they also give you all the different ones.
Yeah, so everything's equal.
So they're all equal mod 41, yeah? Okay.
Wow.
Alright, we're getting to this moment now. Maybe some people, when they feel like they figured it out themselves, they're happier and generous as well. Okay, so they're all equal. Yeah, so I guess this should really say as all the 1000k, right? That's what you really want to say here, yeah?
Yeah.
You want to say 1000k. And then it should be squared, yeah? It should be squared here. And this is squared. 1000k and then squared, yeah? Um, Oh, okay. So now let AK squared equal X. Okay, I'm starting to actually get some of this now. So let AK squared equals X. Okay? That's mod 41. Then the sum of all the squares, AK squared, AK plus 1 squared, all the way up to AK plus 40. Alright, so that's 41 squared, yeah? Is equal to 41x, right? Mod 41. Okay, and then 41 is so 41x is a multiple of 41 squared. X must be a multiple of 41, yeah?
Yeah.
Oh,
Amazing.
41. Oh, good. Since x is the square of one of those, it must also be divisible by 41. Yeah, I guess you really want to say since 41 is prime, right? Yeah? So since AK, so yeah, and then that's done. So they are divisible by 41. Okay, good. So I mean, obviously the main thing is the idea, but you don't want to lose your idea in the transcription of it, right? So one thing I could suggest is, so state the result at the top, yeah? So you're saying they are all multiples of 41, yeah? Then it puts the person in the mindset, yeah? And if it's wrong, it gives them an easier time to mark it wrong.
So,
Okay, so you say it is a multiple of 41. Okay, and then I guess you want to take some more time to prove this claim here. Okay? Yeah? So you want to basically say for any k, so you can consider the k to go infinite, right? As long as you take it mod 1,000, yeah? And anytime you have like a, what is it? Is it ak squared plus, is it a 40? Ak plus 40, right? How is this proof? Ak plus 40 squared, right? That's a multiple of 41, yeah?
yeah. So if we leave the first term and add a k plus 1 square.
Oh, yeah, so you can subtract ak plus 1, right? Minus all the way up to ak plus 41, right? Yeah?
Yeah.
And so that's a multiple of 41, that's a multiple of 41, so the difference is a multiple of 41, so then the difference is ak squared minus ak squared, so they equal, yeah? Okay. Yeah. You know, and some of these things are they're to be expected with junior, okay? Because your minds are like, you're not like an adult person's mind, okay? Let's just be clear about that. There's some things in your mind are not developed. So sometimes you have really good intuition, but you might not have like sort of the mechanism to make it like you know it's right. So it's almost it's kind of when you know something's true, it's less motivating also to try to convince someone. You know what I'm saying? So a lot of the time you're actually just convincing yourself. You know what I mean? And that's kind of why I wrote those proofs before, right? Because I want to convince myself. But if you already know it's true, it's going to be obviously harder to put yourself in that role, yeah? So like when you do junior, you got to take it with that grain of salt. The more junior it is, the more it's about the ideas, okay? The more it is about the ingenuity, okay? Whereas the more senior it is, the more it's about the certainty, the rigor, Okay, and those things are like kind of a dual to each other because you know the more ideas you have, the more you can realize when something's not rigorous because you think of ways it could be wrong, right? Or the more logical rigor you have, right? The more like it goes both ways, yeah. Okay, so that's very good. So 5 out of 5, not very common, okay? Not very common.
I got 5 out of 5. This is such a scam.
How did you write something similar?
Yeah, but with extra long list or extra rigor. So I knew it was right as well, but I still decided to start it just to be safe. I had enough time.
Oh, generate. Can you also say something like, for all I, AI squared equals AI plus 41 squared mod 41 squared. So 41 squared divides 41 times AI squared. Oh, okay. Well, so what's the suggestion? It's instead of saying mod 41, you have mod 41 squared. What if you had mod 41 squared? There are more possibilities. Can you say something more? The 41 squared divides 41 AI squared. The 41. Yeah, so the last part of that is the same, yeah? So 41 divides the square because it's prime, it divides the thing, okay? And then, so I guess it's the whole, is it mod, do you mean mod 41? So if you mean mod 41, then it's the same. If you mean mod 41 squared, we have to think about that. Because if it's mod 41 squared, right, then there's more possibilities for the indices. Um, so what happens if it's like 16j equals 16k mod 41 squared, yeah? Then k minus j. Ah, k equals j. Like the problem said, it was known that the sum of 41 squared is the circle of mod 41 squared. Oh, yeah. So, mod 41 squared, let's see. Okay, so if 16j equals 16k, yeah? Then k equals j mod 41 squared.
Yeah.
Yeah. So then instead of because 16 has nothing in common with 41. So then I guess instead of taking just 41, you could take all the way 41 squared. Yeah, I think this still works. Can you also say something like, for all I, AI squared? Yeah, so how would the argument go? You would say that this is true mod 41 squared, okay?
Yeah.
Hold on. So then you're taking 1,000 mod 41. I'm taking 1,000 mod 41 squared. So 1,000 mod 41 squared, what's that? That's still 1,000 here. 1,000 has no common factor with 41, yeah? It's 2s and 5s. So, okay. And then you get all the a up to 41 squared, right?
Yeah.
And then they're all equal.
Yeah.
The equal mod 41 squared, yeah?
Mm-hmm.
And then you add them up. You get 41 times x, yeah? Mod 41 squared. Um, 41 mod 41 squared. And then this is 41. Yeah, so it's saying 41x is 0 mod 41 squared, right? Oh, okay, so that's the problem here, right? Because if 41x is divisible by 41 squared, yeah? Oh, okay, hold on. So x is divisible by 41. Is that what that means? So this is 41x becomes equals 0 mod 41 squared, right? Okay. So that means x is divisible by 41, yeah? And x is a something squared.
Mm-hmm.
Yeah. I think it's still the same argument, isn't it? And then x, yeah, because it's prime, it goes into both. Yeah, so I guess so if you wanted to modify this argument, you would have to make it mod 41 squared, right? Yeah, yeah. So they're all equal to x mod 41 squared. So they're all divisible by 41, yeah. And if you keep going up by 1,000, because 1,000 is co-prime to 41 squared, right? Yeah. Yeah, so I think it still works, but you might have to be careful to not lose a mark, because it does feel a bit weirder. Hmm. Did they give a reason? I think it still works if you're careful. Let's think. Mod 41 squared. Yeah, so it's saying 41x is a multiple of 41 squared, yeah? That means x is a multiple of 41, and 41 is prime, so that means ak squared is a multiple of 41. Yeah. No, I think it still works actually, because nothing about the argument changed with an extra 41. And I think in some ways your thing is pretty natural because the question is phrased mod 41 squared, yeah? So you have a good point as well. Yeah.